capacity. Okay, so the first thing you were supposed to do here, right, is to basically justify why it would be a rectangle, right? What are two things that would make a shape a rectangle, right? And there's a lot of properties to choose from. If you go to page 190, okay, I gave you a bunch of stuff here. So you could have mentioned, right, two pairs of parallel sides, two pairs of equal sides, right? Diagonals bisect, right? But they're not equal in length, except for this. The rectangle actually is equal in length. So you have so many properties that you could have stated. If you just said diagonals bisect, that's fine, right? And if you said diagonals are equal, that's also fine. And so that you have lots of options to choose from. So on your study sheet, if you have 2 or 3 of each, you're going to be just fine. Okay. So basically, you get 1 for this here and 1 for that. I just gave you more. The diagonals actually meet at a perpendicular, which is, I didn't give you that, but you know, you don't need that many properties. Okay, let's keep going. Number 2, name the following triangles or classify. It's the same thing. The following triangle would be, according to this, right? These two sides are the same and these two angles are the same. This angle is different than the other ones, right? So you have 2 equal sides. So that makes it an isosceles, and they all look less than 90, so we would go acute, right? And this one will be obtuse scalene, because you can tell it's obtuse here, and all 3 sides are different. So there it is. Sketch a rhombus and label all congruent parts. We're going to go with, if you label 2, right? If you labeled at least 2, then you're fine. So let's say you graph, this is a rhombus, so this would be congruent. And these 2 angles will be, as well as these 2. So if you've labeled something like that, you're fine. You could also say that, you know, all 4 sides are equal. It's a little slanted, okay? That's the key with a rhombus. And when you have the diagonals, they are bisected and you meet at a 90 here. So that's not necessarily a congruent part, so you didn't have to have the 90 there. But saying that these 2 things are the same and these 2 are the same, that would be acceptable as well. Oh, you can't see my screen? Oh, wait. Sorry, guys. Thank you for letting me know. I thought I had it. I usually do it right off the bat. Okay, what about now? You see it now? If just 1 or 2, okay. All right, perfect. Let's keep going. So I'm just going to go back one so you can see, right, the 2 properties. I gave you 4 here, but this all goes back to page 190. Okay, so here it is again for those of you at home. I gave you this on page 190, so you could have picked anything from here, right? 2 pairs of parallel sides, 2 pairs of equal sides. Parallel and equal is different, right? You could have said the diagonals bisect. Here specifically to a rectangle, because they're kind of related, right? A parallelogram and a rectangle, but it has 4 right angles here when you look at the rectangle. So that's something that I was looking for there. Just mentioning those 2 things that are unique to a rectangle. And then we label, right? This is an acute isosceles because you've got two sides that are the same. Therefore, the angles will be the same as well. And here, all three sides measure differently. So it's an obtuse. You can tell by this angle it's obtuse, and it's scalene because all three sides are different. Rhombus, label all congruent parts, and I said at least two things. So here, the one congruent part would be that all four sides are the same, and the second piece would be that these two angles and these two angles are equal. Or you could have drawn your diagonals and said that these two sections would be the same and these two sections will be the same, and then I have the sides as well. So it's either this or that would give you the two marks. So if you only have the four sides being equal, you get one mark. And then obviously back up here, you get one mark for this, one mark for that. If you miss one of these pieces, right, you get only half of it. So let's say you mentioned scalene, but you got the obtuse wrong. I would take off half a mark. So now question 1 is worth 2. Question 2 is worth 2 as well. Question 3 is worth 2 marks. Does yours say kite as well? Or does it say trapezoid? No, it's a kite on yours, okay. A kite is a type of polygon. State two properties of this polygon. Again, you go back to page 190 or you remember it, right? The diagonals meet at a 90 and you have two pairs of congruent sides, right? These two and these two. So 2 marks there as well. So far it's 2, 4, 6, 8 on this page. Backside, you should recognize this type of question already. So Martha is building a triangular ramp over a drainage pipe. She's considering the following design. So, right, that's what she's looking for. Choose the letter that best completes the statement below. The type of triangular ramp that allows a wheelbarrow to be pushed smoothly over the pipe with the least amount of effort from either side, so from both sides, would be the obtuse here, right? This would be the one that gives you the least effort going over it. From both sides, that is, right? Because this one here, it'd be easy to come up this end, but it'd be hard to come up this end, right? So obtuse is the best answer here. Justify why this type of triangle should be used for the ramp. So you get 1 mark for the correct choice there. If the top angle is larger, the base angle will be smaller, right? This will make it easier to travel over the ramp, right? So the bigger the top, the smaller these are, right? And smaller at the bases means it's not as steep. So you get 1 mark for justification, 1 mark for this. I would give you half a mark if it sort of makes sense, but it's not quite there, and you decide what that is. But let's say you picked a different one here. You would lose the marks there. But if your justification is in line with what you've picked up here, we still give you the mark here in B. That's how it works. But if it contradicts, then you lose it again. All right, so what's happening here? It's a right trapezoid. Calculate the value of indicated angles and sides. So I asked you what was missing here. This x, right? We know that these two add up to 180. So if this is 50, then this will be 130, right? So you get 1 mark for coming up with a 130. Why did I put 1.5? Oh, yeah. So why was a tricky one? Because you know that this is 2.5, you kind of want to know what this is, because if you find this, you will know that, okay? This is the same as y. So I take out this right triangle out here, I come up with a 2.5 here. And how did I get this 2? Well, I subtracted 6 and 4. If you subtract that, you get the 2 that is here. So you get 1 mark for coming up with this part right here, if you did that at all. And then I'm going to give you another mark for using the Pythagorean theorem. You're trying to find this leg here that we call y. So it'd be hypotenuse squared minus this leg squared, and then square rooted to get 1.5. You get another mark for that. So that's where the 3 marks come from for question 6. So with the multiple choice, the explanation, and this question here, you have 5 marks on that second page. So that gives it a total of 13, right? 8 and 5 is 13. So give a mark out of 13 there. And I will open a slot right now for you to upload it. It doesn't matter what you got, okay? I want to see it. So you will see an AC3 triangles upload here right now. So let's take a couple minutes and do that, and then we'll do AC4 after that. So even if you're here, if you can take a picture and upload it, then you get you can keep that paper that you have. Question? Yeah. If you feel like you need extra practice, I'll be posting them after this class, and they look like this. Like one looks like that. Polygon geometry hand-in has like a chart in the front, and the other one looks like this. And these are old exam questions, by the way. So I'll post them with the answer key in case you need it. Okay, so here you go. Start marking. So you get 1 mark for each correct label. So if you somehow have the central angle labeled, okay, to basically go to the middle and go out to one vertex, and then the other one that's connected with that side. That's the central angle right there. Interior, any one of these interior angles labeled, you get the mark for that. And exterior, you basically just extend one of the sides and you label exterior there. So 1 mark each. Okay. B, calculate the sum of interior angles, realizing that n is equal to 9, right? Like there are 9 sides here. So everything is worth 1 mark basically. So n minus 2, which is 7 times 180, that's 1260 degrees. Okay, 1260 degrees. If you forgot the degree symbol in any one of your answers, take off half a mark up to a maximum of 1 per page. Interior angle is n minus 2 times 180 divided by 9. So you basically take the previous answer, divide it by 9, you get 140 degrees. So each one of these inside here measures 140 degrees, and they add up to 1260. You have to understand that. Calculate the measure of one exterior angle. I need you to know, right, that the interior and the exterior add up to 180. So technically, if you just go 180 minus the interior you just found up there, that it is 40 degrees. However, if you use the formula, you get 40 as well. But you should be comfortable with both methods of doing it. Keep going. Calculate the measure of a central angle, that's also 40. Calculate the number of diagonals, so it's n times n minus 3, which is 6, divided by 2, you get 27. And this was a bit of a trick question. What's the sum of exterior angles? It's always 360 degrees. Okay, it's always that. So this is out of 9 so far. That page is out of 9. So add it up. Out of 9, it should be fairly simple to do because everything is worth 1, except for A, because you labeled 3 things, right? That's worth 3. And the back side. I'm going to cover the rest for now. If a polygon has a central angle of 20, how many sides does it have? Calculate this. You can't guess it, okay? They're giving you the central angle, so we're going to use the formula. In this case, they give you C, right? So you plug that into C, and you keep the other side the same. You put a 1 down here, and that allows you to know that you have to cross multiply here and divide by 20. So it's 360 times 1 divided by 20, which is 18 sides. Okay, so I'd give you 1 mark for setting it up here, and I would give you 1 mark for the correct final answer. Continue. This is going to be out of 5 marks, 1 mark each, right? We have a hexagon, so we know that n is equal to 6. Make sure you have those prefixes. It's also in your booklet, okay? The sum of interior angles, it's just n minus 2, which is 6, times 180. I flipped it. I know it doesn't matter, right? As long as you're multiplying them, so that's 720. A central angle would just be 60, because you're going 360 divided by 6. So 1 mark there. One interior angle, it's 120. You just went 720 divided by 6, right? Like the sum is really divided by 6, which is 120. Number of diagonals, you use the formula, right? N times n minus 3 divided by 2, you get 9. The measure of one exterior angle is 60 as well, using the formula. Or you could have gone 180 minus the interior, which is also 60. Okay, so that's 5 marks. Okay, 1 for each. There. Should be fairly easy to mark. And then number 4, determine the sum of interior angles. You just count, right? 1, 2, 3, 4, 5. This is a 5-sided polygon. It's just not a regular polygon. So it's 180 times 3 essentially, which is 540. Determine x. Well, you know all angles except for 1. So you take the 540 you just calculated and start subtracting. I have two 90-degree angles, right? That's why I went 2 times 90. But just start subtracting all the ones you know, and you're left with the one unknown. So I would say 1 mark for showing some kind of work and 1 mark for coming up with the final answer. That's also 9. Okay. So I will also make something